In a single crank, single-acting compressor, the low-pressure and high-pressure pistons are connected in tandem to a single crank. In low-pressure stage, when the piston moves down, the atmospheric air is inducted. The compressor air from the first stage flows to the second stage through the intercooler. The pressurized air is inducted into the second stage. As the piston moves up, compression takes place in both stages. The high-pressure air from the second stage is delivered through the aftercooler. In a single-acting, two-crank compressors, the low-pressure and high-pressure pistons are connected to two separate cranks. As the low-pressure piston moves down, air is inducted through the air filter. When it moves up, the air is compressed and delivered to the second stage through the intercooler. The air is further compressed in the second stage, and high-pressure air is delivered through the aftercooler. In a double-acting compressor, compression takes place during the upward as well the downward stroke of the piston. In this arrangement, the low-pressure first-stage piston is at the top and the high-pressure piston is at the bottom. In the first stage, as the piston moves up, air is compressed and the compressed air is inducted into the second stage. When the piston moves down, the pressurized air is further compressed in the second stage. In the meantime, the low-pressure stage inducts fresh air from atmosphere through an air filter. In this way, the process is cyclical. In three-stage compression, the air is inducted at the first stage, compressed, cooled by the intercooler, and delivered to the second stage. In the second stage, the air is compressed further and delivered to the third stage. In the third stage, air is compressed to the required pressure and delivered through an aftercooler. When the piston moves up, air is compressed in the first and third stages, whereas air from the first stage is inducted into the second stage.